Hello friends, in this problem I will illustrate how you can apply energy conservation in case of a vertical circular motion. So this problem is called a dumbbell in vertical circular motion. So the problem says a dumbbell consists of two masses A and B, each of mass M joined by a light rod of length L with mass B attached to the suspension point O by a light rod of length L as shown in the figure. Find the minimum required speed with which mass A to be projected horizontally so that the system completes the vertical circular motion. So let us plan this problem. So what are the things that is given? So you have been given a dumbbell. So this is the dumbbell you have. And this has a mass M, and this also has mass M, and this length is L, and let's call this as A and this is B. Basically this is A and this is B. This mass is given, so the lower one is given velocity u. Then you have to find what should be the minimum value of u so that it completes the vertical circle, and this length is also given L. Now how will you do this problem? So the first thing you have to do is you have to draw the diagram, determine the change in potential energy, determine the change in kinetic energy, and use the energy conservation. So let's take 1 minute break and then we will meet again. So you solve this problem. Okay, so let us see the solution for this problem. So we will solve this. So this is the situation, that is t is equals to 0, and this is the situation t is equals to t when the ball has reached to the maximum height, that is dumbbell has reached to the maximum height. Question says this just reaches to the maximum height or just completes the vertical circle. This means at this point there will be no velocity. Velocity of 0 of this mass and velocity is 0 of this mass also. So now what is the initial kinetic energy and what is the initial or you can say what is the change in kinetic energy and what is the change in potential energy. So let us first find change in potential energy. So change in potential energy. What will be the change in potential energy? Initially, so let's say initially your dumbbell was here, another dumbbell was here. This length is L, this length is L. So this mass has basically moved here. So this has traveled a distance of 4L. So this is L, this is L. So in vertical direction, this has gained mgh and h is 4L. What about this mass? This mass is here, now it is here. So this has basically gone to a vertical distance of 2L. So this has gained a potential energy of mg2L. Now let us find loss in kinetic energy. Loss in kinetic energy. So as I said, finally there is no kinetic energy because everything is at rest. So kinetic energy is 0. What was the initial kinetic energy? For this mass, kinetic energy is half mvs square. What about this mass? This mass is also moving. Now, what will be the velocity? Now, this is half mu square basically. So, what is the velocity of this mass? Or what is the speed of this mass? So, see, this will be u by 2 because this is moving in a circle of 2L and this is moving in a circle of L. So, omega has to be constant. So, you can basically calculate for this mass omega times 2L is equals to u. So this means omega times L is equals to u by 2, and omega times L is nothing but velocity of this mass, that is omega times L. So omega times L is equals to U by 2. So loss in kinetic energy. So this total kinetic energy of this mass has lost, that is half mu square. And the kinetic energy of this mass is half mu by 2 square, that has also been lost. So this is U by 2. So now I can equate change in potential energy, or you can say basically this is gain in potential energy. So gain in potential energy is equals to loss in kinetic energy. So what is this? So this is 6 mgl, and this will be half mu square plus, and this will be 1 by 8 mu square. So this will be 1 by 2 plus 1 by 8 mu square. So from here you can say 6 mgl is equals to 5 by 8 mu square. M cancels out. So u square will be 48 divided by 5 and then gl. So from here you can say u is equals to a square root of 48 by 5 gl. So u will be, so this will be, you can also write, so 4 a square root of 3 gl by 5. So if we apply this minimum velocity, then this will reach to the maximum height, or it will complete the vertical circle. Now question for you, what will happen to the dumbbell if I impart a velocity that is greater than 4 under root 3 gl by 5? So what will happen? In this case, will that dumbbell have some kinetic energy? Will that dumbbell will have some velocity at the top point? What will be that velocity? And another situation, what will happen if I give this dumbbell a velocity that is less than 4 times 3 gl by 5? So let us discuss these two situations in the comment box, and I will see you in the next video. I hope you like this video. If you like, please share and subscribe to my channel. Thank you.